So to stabilize the molecule, to normalize the amount of energy, the S character flow is more on this side. Definitely the P character value will be comparatively less on this side because total hybridization is sp3 only. So S character flow has been increased to 33.33% from 25%. P character value is 75%. So increase in the S character will normalize the amount of energy of the molecule as a whole. But this S character flow has been increased on this side. So definitely P character value, P character flow will be there on the opposite side. Let us talk about the carbon and fluorine bond. Fluorine atom is more electronegative than carbon atom. So fluorine atom will become delta negatively charged, carbon atom will become delta positively charged. So flow of more electron density will be there towards the fluorine atom. But it will not raise the amount of energy. So definitely P character flow is more on this side. It is 75%. But this increase in the P character flow will not increase in the amount of energy of the molecule as a whole because fluorine atom is not responsible for the hybridization. It is the carbon atom which is responsible for the hybridization. So accumulation of the more electron density towards the fluorine atom is not at all going to raise the amount of the molecule as a whole. So this increase in the P character will not affect the amount of energy of the molecule. So a stable fluoromethane molecule is formed. So this was the explanation given by the Henry Bent. ફરી એક વખત આટલે સુધી સમજાઈ દો પહેલેથી શરૂ કરીને અને પછી એનો આ હેનરી બેન્ટ નો રૂલ છે એક્સપ્લેન ધ હેનરી બેન્ટ રૂલ તો આટલે સુધી સમજાવવાનો ફરી એક વખત સમજાવું છું ડ્રામેટિકલી આ બોન્ડ નાનો દોરજો અને આ બોન્ડ મોટો દોરજો બોન્ડ એંગલ ઓકે હેનરી બેન્ટ નો નિયમ લો હેનરી બેન્ટ્સ રૂલ with the various fluoromethane where more electronegative substituent like fluorine atom is present, bond angle decreases nearly becomes equal to sp3 hybridization with P character value high, that is 75%, or S character value is low, that is 25%. On the other hand, where the more electropositive substituent like hydrogen atom is present, bond angle increases nearly becomes equal to sp2 hybridization. So that bond angle is 120 degree here, 109 degree, 109 degree, 28 minute, 25 or 20 or 0.5 degree, whatever it will be. So here it is with the lesser amount of the P character, that is 66.66%, or higher percentage, higher amount of the S character, that is 33.30%. जो आ बाजू કેટલી હતી ફ્લોરિન એટમ બાજુ 25% હતી અને હાઇડ્રોજન પાસે વધારે છે 33.33%. અથવા P character ની વાત કરીએ તો ફ્લોરિન એટમ પાસે વધારે છે અને P character hydrogen atom પાસે ઓછી છે. Right? This is the Henry Bent's rule. ફરી એક વખત બોલી દો. With the various fluoromethane, where the more electronegative substituent like fluorine atom is present, bond angle decreases, nearly becomes equal to sp3 hybridization with the more P character and less S character. On the other hand, with the more electropositive substituent like hydrogen atom अथवा less electronegative substituent like hydrogen atom, the bond angle increases, nearly becomes equal to sp2 hybridization with the lesser p character and more s character, 25% to 33.33%. રીઝન એમણે જે આપ્યું કે શા માટે આવું થવું જોઈએ. So where the more electropositive substituent like hydrogen atom is present. So this bond is a polar bond where carbon atom is more electronegative, so it will become delta negative. Hydrogen atom is less electronegative, it will become delta positive. So a more flow of the electron will be there towards the carbon atom. Increase in the electron flow towards carbon atom will raise the amount of the energy of the molecule, because due to accumulation of the more electron towards the carbon atom, more mutual repulsion that will occur, and that will increase the amount of the molecule as a whole. And carbon atom is responsible for the sp3 hybridization. 2s orbital, 2px orbital, 2py orbital, and 2pz orbital of the carbon atom will make it sp3 hybrid orbitals. So more accumulation of the electron or electron density towards the carbon atom will raise the amount of the molecule, which will make the molecule unstable. To stabilize this, the rearrangement of the s and p character occurs within the molecule. So it will raise the amount of the s character on this side. We know that s orbitals are having lower amount of energy than p orbitals, right? So s orbitals are having lower amount of energy. So flow of more s character on this side will again bringing it back to the energy level to stabilize the molecule, to stabilize the system. So more s character will be there towards a more electropositive substituent like hydrogen atom. So definitely it will decrease the p character because total is same one. Total is sp3 hybridization. So here it becomes equal to 33.33%, and here it becomes equal to 66.66%. On the other hand, what will happen with the more electronegative substituent like fluorine atom? Fluorine atom is more electronegative than carbon atom. So fluorine atom will become delta negatively charged, carbon atom will become delta positively charged. A flow will be there towards a fluorine atom. But fluorine atom is not at all responsible for the hybridization. It is the carbon atom which is responsible for the sp3 hybridization. So accumulation of the more p character, more electron density towards the fluorine atom will not at all affect the stability of the molecule. So here it will not raise the amount of the energy of the molecule because fluorine atom is not at all responsible for the hybrid orbitals. So therefore the increase in the p character on this side, that is 75%, will not at all affect the energy of the molecule as a whole. So a stable fluoromethane molecule is formed. Is it okay? Atle સુધી બેન્ડનો નિયમ, is it okay?
Yes sir.
Good. માત્ર આ ફિગર યાદ રાખજો, આના ઉપરથી બધું જ લખી શકાશે. sp3 hybridization, s character 25%, p character value 75%. આ બાજુ મોટામાં મોટો બોન્ડ એંગલ બતાવજો, હાઇડ્રોજન હાઇડ્રોજન near equal to sp2 hybridization, s character value 33.33%, 25 to વધીને 33%. p character value decrease થાય છે 66.66%. 75% હતી, એમાંથી 66.66%. આ ફિગર ઉપરથી બધું એક્સપ્લેનેશન તમે લખી શકશો. હવે let us see the relationship between એમણે બોન્ડ એંગલ ઉપર એક્સપેરિમેન્ટ કર્યો. He carried out the experiment on the various molecules having the same number of the bond pair, same number of the lone pair. The first one is oxygen difluoride. Bond angle is 103 degree, 8 minutes. With the water molecule, 104 degree, 5 minutes. With the methanol, 107 to 109 degree, and dimethyl ether, it is 111 degree. Now see, all the molecules are having the same amount of the number of the lone pairs and same amount of the bond pairs. Even though the difference is there in the bond angle. એના માટે એમણે explanation આપ્યું કે this is sp hybridization with bond angle 180 degree. Here P character value is 50%. On this side, with sp2 hybridization, bond angle is 120 degree. With the P character value is 66.66%. On the other hand, with the sp3 hybridization, it is 109 degree, 28 minutes. So here 109 degree, 28 minutes. With the P character value is 75%. Now let us see the relationship between the bond angle and the P character percentage. Bond angle value increases, that is 109, 120, 180 degrees. So going from this side, it decreases the P character value 75 to 66.66% to 50%. So P character value decreases. Bond angle increases 109, 120, 180. So going from right to left, bond angle decreases, P character bond angle increases, P character value decreases. Or either we can say, if we go from left to right, bond angle decreases 180 to 120, bond angle decreases, P character value increases. So it is inversely proportional. Bond angle and P character value, which is common with the sp, sp2, sp3 hybridization. It is inversely proportional. Now let us see in this particular case, in the case where he studied out, Henry Bent carried out the experiment on the various molecules in which the number of the bond pairs and lone pairs, they are identical. Oxygen difluoride. Now fluorine atom is more electronegative, right? So we have seen in the Bent rule that where the fluorine atom is there, P character value is comparatively high. So with the higher P character value, a bond angle. See what we have seen, relationship, it is inversely proportional, bond angle increases, P character value decreases, or P character value increases, bond angle decreases. Right? It is inversely proportional. So where the P character value is maximum, bond angle is minimum. You can see 103 degree 8 minute. Compared to fluorine atom, hydrogen atom is there. Hydrogen atom is less electronegative. So P character value decreases. If P character value decreases, bond angle should get increased because it is inversely proportional. So that is reflected here from 103 degree 8 minute. It increases to 104 degree 5 minute. Both the atoms are hydrogen atoms. Both the groups are hydrogen atoms. Now here with the methanol, one of the atoms is hydrogen atom, but second atom is CH3 functional group. CH3 group. We know that it is having plus I effect, CH3 group. Hydrogen atom is less electronegative. It has some tendency to attack the electron pair towards itself. This percentage is very, very less, so it is less electronegative. But methane group, it doesn't have the tendency to attack the electron. On the contrary, it has capacity, it has tendency to donate the electron pair towards the other atom, plus I effect. So that further decreases. So P character value further decreases. This decrease in the P character value further increases in the bond angle. With the dimethyl ether, અહીંયા તો એક હાઇડ્રોજન એટમ હતો. હવે now in this case both the methyl groups are present. Both are having plus I effect, plus I effect. That further decreases the P character value, further increases in the value of the bond angle. ફરી એક વખત સમજાઈ દઉં. Henry Bent carried out the experiment on the various molecules in which number of the bond pair, number of the lone pairs are identical. See, this explanation, increase or decrease in the bond angle, cannot be explained by the VSEPR theory. That is the limitation of the VSEPR theory, but that was explained by the Henry Bent. It was explained by the Henry Bent. So, with the oxygen difluoride, fluorine atom is more electronegative. Now, what Henry Bent rule suggests, where more electronegative substituent is there, P character value is maximum, is very high, so that bond angle value will be comparatively low. So that is 103 degree minute. So now coming back to the second molecule, it is the water molecule, in which instead of the two fluorine atoms, two hydrogen atoms are there. So we know that hydrogen atoms are less electronegative. With the less electronegative substituent like hydrogen atoms, that will decrease the P character, that should increase the bond angle. That is what Henry Bent found out. From 103.8, it becomes equal to 104 degree 5 minute. With the methanol, one more step ahead. One hydrogen atom is there. Hydrogen atom is less electronegative. Still some tendency is there to attack the electron pair towards itself. But the second group has been replaced by the methyl group. Methyl group doesn't have tendency to attack the electron. On the contrary, it has plus I effect, plus inductive effect. So that will donate the electron to the centrally situated atom. So P character value further decreases, that further increases the bond angle from 104 degree 5 minute to 107 degree to 109 degree. Lastly, with the dimethyl ether, Both the groups are methyl group. Here in the previous case, one hydrogen atom was there. Now in this case, both the atoms are methyl group. Both are having plus inductive effect that further decreases the p character value, that increases the bond angle from 107 to 109 to 111 degree. So this is the relationship with the bond angle and hybridization. અથવા તો બેન્ટ રૂલ અને બોન્ડ એંગલ ની રિલેશનશિપ. આટલા સુધી ઓકે છે મિત્રો?
Yes, sir.
Good. Any no question? લાસ્ટ પાર્ટ લઈ લઈએ. આ બોન્ડ એંગલ ની જો પેપર માં ધ્યાન રાખીને સવાલનો જવાબ લખજો. હેનરી બેન્ટ રૂલ, પછી બોન્ડ એંગલ અને બેન્ટ રૂલ, અને બોન્ડ ડિસ્ટન્સ અને બેન્ટ રૂલ. આ બંને સવાલો જુદા જુદા છે. એટલે કયો સવાલ હોય આ તો શક્યતાની વાત છે, પૂછાયેલો હોય તોની વાત છે. બોન્ડ એંગલ અને બેન્ટ રૂલ અને બોન્ડ ડિસ્ટન્સ અને બેન્ટ રૂલ, બોથ આર ડિફરન્ટ આન્સર. So last part, bond distance અને bent rule. So generalized statement છે where we have the carbon the bond distance is 1.54 angstrom. C double bond C છે, it is 1.50 angstrom. C triple bond C છે, ત્યાં 1.46 angstrom. This is sp3 hybridization, sp2 hybridization and sp hybridization, where p character value is 75%, p character value is 66.66%, p character value is 50%. હવે બોન્ડ ડિસ્ટન્સ અને p character value વચ્ચે કોરિલેશન આપણે ડેવલપ કરીએ છીએ. 1.54, 1.50, 1.46. So bond distance decreases going from left to right. Bond distance decreases. What about the p character? 75%, 66.66%, 50%. So p character value also decreases. It is directly proportional. Or if we go from right to left, 1.46, 1.50, 1.54. So bond distance increases. What about the p character? 50%, 66.66%, 75%. So p character value also increases. So bond distance and p character value both are directly proportional to each other. Now let us see for the experiment what Henry Bent carried out with the monofluoromethane. 1.388 angstrom. With the difluoromethane, it is 1.358 angstrom. With the trifluoromethane, it is 1.329 angstrom. And with the tetrafluoromethane, it is 1.323 angstrom. Now here one fluorine atom is there. Total is what? Total is sp3 hybridization. So whatever flow of the more p character is there is with only one fluorine atom. Whatever p character is there, total is 75% only, right? Total is 75%. So whatever more flow is there with the more electronegative substituent is only shared between one fluorine atom. So here P character value is comparatively high. It is with the only one fluorine atom. Whatever may be the P character value is there, it is with only one fluorine atom. So here P character value is maximum. So P character value is high. So bond distance also should be high. It is 1.388 angstrom. Now P character value is fixed. It is totally 75%. Now with the difluoromethane, the P character value flow will be there on this side, but it will be shared between the two fluorine atoms. The more flow of the electron, more flow of the P character will be shared between the two fluorine atoms. In the previous case, whatever may be the more flow of the P character was there, it was only one fluorine atom was having it. In the second example, it is shared between the two fluorine atoms, right? So therefore, P character value decreases. P character decreases, then bond distance also should get decreased. From 1.388, it becomes 1.358 angstrom. Now here, the P character flow will be more towards a more electronegative substituent, but these more flow of the electron, more flow of the P character will be shared between the three fluorine atoms. So P character value further decreases. That should further decrease the bond distance from 1.3582. It decreases to 1.329 angstrom. And here all are fluorine atom. So all are fluorine atom. So more flow of the P character will be equally shared between the four fluorine atom. So that further decreases the P character. That should also decrease the bond distance from 1.329. So it decreases to 1.323 angstrom. So this is all about the Henry-Bent rule. Any points require the clarification? જો આમાં પરીક્ષામાં છે ને 4 સવાલો મુખ્ય હોઈ શકે. એક તો વોલ્સ ડાયાગ્રામ જે આપણે કાલે લઈશું. વોલ્સ ડાયાગ્રામ જુદા જુદા મોલેક્યુલ્સ માટે હોઈ શકે. પછી હેનરી બેન્ટ રૂલ, પછી છે એક HMO થિયરી પરનો એક ન્યુમેરિકલ હોઈ શકે, અને બીજો એક ચોથો ક્વેશ્ચન છે VSEPR અને VSIP થિયરી છે. એ આપણે એના પછીના દિવસે બંને થિયરી એક સાથે લઈને આપણે પરમ દિવસે કમ્પ્લીટ કરી દઈશું. ના, on Monday we will complete it. So Walsh diagram, Henry-Bent rule, HMO theory, VSEPR अथवा VSIP theory. આ 4 અગત્યના પોઈન્ટ્સ છે. Any question related to this Bent rule?
No, sir.
Good. So I am ending this session about to 1 o'clock. So no question. Let me end this session. Have a nice day.